Okay, this is problem number 9 on the Trig final review, and it is a straightforward identity problem. It gives you an identity and asks you to prove that this statement is actually a true statement. There's an implication here that it is true, and it's just up to you to actually prove that it's true. Generally speaking, it would be extremely difficult to prove that it's false. So we don't generally ask our students to do that. So you can expect that there is a solution to this and a way to work it out. Now, I haven't done a lot of the videos on identities yet. I've kind of directed you to where you can find some, and you've got a book. There's plenty of examples there, and I will get some more videos coming to explain just the general process. But one of the basic rules of thumb for solving identities is to convert, okay, so let's start from scratch. Generally speaking, you work on the left side, try to make it equal to the right. Sometimes the way they word that is find the more complicated side, work with it to simplify it into this, rather than trying to take something like this and up-complicate it to something like this. That would be kind of difficult. So let's just go ahead and start working on this side and see if we can make it look like this side. The other thing that is kind of a rule of thumb is if you're not really sure what to do, the best thing in terms of starting an identity problem is to convert everything into sines and cosines. We've already got cosine here, we already got sine here, so converting this into sine or cosine might be a way to get started with this, and then we can kind of see where it's going to go. The other thing that comes in a great amount of time on solving these identities is that somehow, one way or another, one of the Pythagorean identities, we already saw that with a couple problems ago, how the Pythagorean identity played into that. Well, you'll see where it plays into this one as well. This takes a few steps. I just worked it out, and I kind of showed some extra steps, but it looks like 1, 2, 3, 4, looks like about 5 or 6 steps. But they're all pretty straightforward, and they kind of fall together once you get started. So let's go ahead, let's do this conversion. This is 1 over sine theta times cosine squared theta okay. This essentially, when we do this multiplication, becomes cosine squared over sine plus sine. So let's do that. Cosine squared over sine plus sine. Yeah, I'm going to leave some space because I know what's coming. So at this point, you might be thinking, well, what now? Well, you've got a cosine squared here, and anytime you see a cosine squared or a sine squared, I'm usually trying to think, how can I find a sine squared to go with this cosine squared and use the Pythagorean identity to make that a 1? Well, I'm part of the way here, but that's not sine squared. However, if I wanted to combine these two things, I would need similar denominators. And to make this have a denominator of sine, I would have to multiply the top and the bottom. The sine, this is essentially sine over 1. And I'd have to multiply the top and the bottom by sine, like this. Well, look what I get. I get sine squared over sine. So now I've got cosine squared. This is sine squared. This is over sine. Plus sine squared. Okay. Now I can combine these two fractions. They both have the same denominator. So I get cosine squared theta plus sine squared theta And we know from our Pythagorean identity that cosine squared theta plus sine squared theta is really just 1. And we know that 1 over sine is cosecant. So what we've successfully accomplished, and this is a nice example of an identity, we started with some statement that says these two things are true. Can you show us that it really is true, or why? And yes, just by simply converting everything to sine and cosine, combining similar denominators by multiplying this by sine over sine, it pretty much fell into place using the Pythagorean identity. And this is a pretty straightforward take it to the bank identity, and not too difficult, and just pretty much like the one that you're going to see on the final in a lot of ways. So there you go.